Awesome work around here. So, check this out. Typical dice. None of you had typical dice. Nobody here had typical dice. There's what the blue histogram was. Those of you that had the blue dice should look like this, right? I got an average of the blue dice of about 8.2-ish with a plus or minus of 2.65. Notice it's skewed left, which means that there's more area to the right. So the blue dice is slightly right-leaning, left skewed. You've got this goofy like trimodal finger thing going on. Totally cool distribution. But definitely not a bell curve. Definitely not a bell curve. A slightly higher average, wider standard deviation. You've got everything from 2 to 12, but not in the same way that you could with fair dice. Good with them so far? There's your yellow dice. Those of you that had yellow dice, it would look something like this. And I noticed these were the couple of ones I was looking over shoulders for the yellow dice. You guys got very low averages, yes? Very low averages. Pretty wide standard deviations, again, 2.2, but mostly because you had this tail that's just going out to the side here. But the majority of the data is happening down there on the low end, hence a lower average. So this is skewed right, leaning left. Fair? Green was the perfectly symmetrical flip 'em the bird distribution. I love this one. I love this one. I was actually trying to make a distribution that was U-shaped. I was trying to make a distribution that was shaped like this. And then I realized after I'm going to show you how I created these things in a second. It's actually kind of a fun use of Excel. I realized after about 5 minutes, you can't get one. Why? Why couldn't I get a perfect U-shaped distribution? I really wanted one. It's called a Y-hole. Why couldn't I get a perfectly U-shaped distribution for these? I was trying my damnedest.
Can I have 2 averages on the outside?
Mm-hmm. In order to have a lot of numbers down here, I'd have to have a lot of snake eyes, ones and ones. And in order to have a lot of numbers over here, you have to have a lot of 6s and 6s. Well, if you got a lot of 1s and 6s, what else do you have a lot of?
7.
By definition, right? So that was the problem. I had to use the bird to get the symmetry. So here's orange. This was the goofiest one of the bunch, I think. Orange is this goofy one. You just got these spikes. You guys, a lot of 4s, right? I remember that looking at you. Got a lot of 4s, a lot of 9s, totally bimodal. And then the red ones were actually somewhat bell-shaped. Somewhat bell-shaped, but the average is wickedly high because you guys had those huge numbers. Lots of 6s, lots of 5s, lots of 4s. You couldn't get 5 and below. There weren't enough available values on there. Now, let me just show you real quick. This is how I actually came up with these dice. I created the same chart I just told you guys to create over there. But what I did was I put random values in for the dice values there. So where you guys put your numbers in, I put random values from 1 to 6 in, and I just kept pressing F9. Oh, look, that's fun. So I took screenshots of it. I took a screenshot of it, and then I was able to build the dice from that. So I just kept that. Oh, well, look at it. I wish I could see that one. That's freaking rad. 9 of each.
That's dreadful.
That is print screen. Let's save that one. That's freaking rad. I mean, seriously, I wouldn't have thought of that one. That's freaking dreadful. But this is case in point of why you can't make a U. Why you can't make a U. You can't, that's, yes. So anyway, I just kept doing this, and every time I felt something was kind of interesting, I decided to take a shot at it. So that's what you're looking at. So here's the question I want to leave you with. Here's a question I want to leave you with. Uh-oh. You see all these numbers down here, mu's and sigmas, mu's and sigmas, mu's and sigmas. That's wonderful and fantastic. But the problem is, the only reason you can call them mu and sigma is because you were able to take the dice and actually turn each die and account for every single possibility. How realistic is that in the world that we live in, as far as getting the idea about a population? It's completely unrealistic, right? I mean, that's like saying, if I'm interested in knowing, I think the example I used in class earlier today was, if I want to know what percentage increase I get for an ADHD kid as far as time on task for 30 milligrams of Ritalin a day versus 15 milligrams of Ritalin a day. In order to do it this way, I'd have to find every kid with ADHD and then break them into 2 control groups, but they wouldn't even be called control groups, so it had every single kid. And in the time I'm trying to do that, some of them age out of the study, new ones come in. It's impossible to do. You can't do it the way you just did it. So what do you do instead? You sample. Go ahead, Corey, what'd you say? I'm sorry.
No, I was yawning after I said sample.
You said you were yawning after you said you're going to take it. So on Monday, make sure you guys remember what color dice you have. We're going to put you in the same groups again on Monday. And we're going to take samples of these die rolls to try to see if we can figure out these values without having to actually count all the sides. That's the beauty of statistics. This is the beauty of it. This is actually statistics, not parameters. Make sense? Okay, you guys have a good weekend? I put a quiz up for next week, but I shoved it back till Wednesday because oh, and bring the normal questions. Bring normal distribution questions for Monday. Yes? It's just the next homework assignment. If you bring questions on that for Monday, make sure those get all knocked down. And if you don't mind dropping the dice up here, that'd be fantastic.